Welcome to Graph Connect. I'm going to kick it off with a little bit of a story. 15 years ago, I was on a plane, I was on a flight to this city, to Bombay. And I was in a little bit of a trouble. I was the CTO of a small startup in Sweden, young fledgling startup. And the problem that I had was, as the CTO, our development velocity wasn't where I wanted it to be. And that's probably true for anyone who's leading a development. I mean, you can never move as fast as you want to, but it was going unusually slow. And something was really holding us back. And for the first time in my career, which was probably short at the time, but I'd worked quite a lot with data, the database was holding me back. All my previous experiences, the database had been an accelerator. It had been something that was made life easier. But for some reason, it was holding me back. We had a team of probably about 20 developers, and half of them spent the majority of their time fighting with the relational database. This is the late 90s, early 2000s. No, actually late 90s. And we had the standard architecture at the time, a 3-tier architecture, where the bottom layer was a relational database, Oracle. We happened to use one called Informix. We had a middle layer, an application server, and then a presentation layer. So very standard architecture. But there's something was new. Something made it really, really painful to work with a database. And so we started thinking about this. We were building enterprise content management systems. And enterprise content management is a lot about folders that you put folders in, and then ultimately you have files in there, which is a hierarchy, which is a graph, but it's a tree. We also had a lot of security that we overlaid on this because we used what was called at the time an ASP model. For those of you who were around back then, application service provider, which today is called SaaS, which meant that while we had hundreds of customers and they all logged onto our system, they all got their own little logo, it looked like they had their own individual instance. Of course, it all ran off of the same system. And we had customers like the Swedish Defense and like a small 2-person ad agency. And it would be a very career-limiting event if the content from the Swedish Defense leaked out to the ad agency. So we had a sophisticated security model where people could belong to groups, groups belonged to multiple groups. A group could have read access to this folder, another group could have write access to that folder. If you had taken an individual and you want to resolve whether they can have access to this file, you had to traverse all these groups, look into all these permissions, all the folders that they belong to, right? So big, connected, networky, graphy mess. And we tried to squeeze that into the relational database, and it worked, but it was painful. So we started thinking a little bit more about this. Okay, so what's the problem here, right? Okay, so there's a mismatch in the abstractions that our infrastructure exposed and the shape of our data. And so then we thought to ourselves, okay, so in the world going forward, are we going to have more or less connected data? Well, the world is kind of getting more and more connected, even back then. So there's probably going to be more of that. And if this is connected data is such a poor fit for the relational database, there seems to be a tension here. And so we thought even more about this, and we realized, okay, really what we need is a database that works exactly like the relational database, of which I was and remain today a big fan. I think the relational database is an amazing piece of technology. Worked exactly like the relational database, but with a new data model. But a data model that was more flexible and was a better fit for the problem at hand. So we started, Alta Vista-ing around, and X-iting around, and Lycus-ing around, for those of you who remember those names, and to try to find this database that worked exactly like a database should work, but had this networky, connected model instead. And of course, we didn't find anything. So then, brilliant and smart as we were, we made the responsible and mature decision to say, we'll just build it, come on. How hard can it be? As it turns out, 15 years later, it was pretty hard to build that database. But that's really what got us started. So when I was on this flight to Bombay to kick off this project, we grabbed a napkin and we started sketching out what today is called the property graph model. And it's a very simple model. The idea is that with 3 core abstractions, you can represent everything, right? You have nodes, you have typed relationships between these nodes, and you have key value pairs that you can attach an arbitrary amount to the nodes and to the relationships. And with that, you can model a social graph. People who know other people, where we have nodes, we have relationships, and we have properties on the node saying name is something, age is something, etc. But we can also attach properties to the relationships, saying that on a scale from 1 to 10, I am a 3 friend with this individual, or saying that we've been friends since this particular date, for example. Very simple and primitive model, maybe even simplistic, but also very powerful. With that little model, you can start evolving that. You can't just store a social graph, you can store other things. You may build a little social application, but after a while it starts taking off and people start saying that, hey, I want to sell stuff. I'm selling gardening tools, right? And so then you create a relationship which has of the sell type between an individual and that particular product. And then you have other people viewing those products, etc. All of a sudden, you've built a little kind of a Facebook meets Craigslist, like a Craig's book type thing. All with this, just 3 core abstractions. A simple model that allows you to evolve very, very, very easily. What's amazing about this model is what I just said, the fact that you can easily evolve your data as business requirements change. What's even more amazing is if you put this data model into an infrastructure that can do this at this scale with whatever 7, 8 graphs, but also at this scale with 1 billion people that are selling and buying things in this Craig's book startup that we're just building together collectively in this room. If you have this type scale with 1 billion people using this, buying and selling things, that's a massively valuable company, all based on this tiny little abstraction of nodes and relationships between them. That's how it started. 15 years later, that napkin has turned into an industry. So now we have industry analysts like Forrester saying things like, graph analysis is the true killer app for big data, and they estimate that over 25% of the enterprise will be using graph databases in production next year. And Gartner, not to be undone, saying that graph analysis may be the single most effective competitive differentiator for enterprises outside of capturing data in the first place, and that 70% will be evaluating by the end of 2018. Neo4j is today the most popular graph database by any objective metrics that we've been able to figure out. So we have a little bit of a privileged view of this transformation. And we see graph databases being picked up in a wide range of diverse industries. Of course, the obvious one is software, right? But also financial services, very popular here in London, of course. Retail, 4 of the top 10 biggest retailers on the planet use Neo4j. Media and entertainment, social, telecom, and industry is centered around networks, and then healthcare. Some of the biggest companies on the planet are using Neo4j are using Neo4j in production across a wide range of use cases. But I'm not going to take an industry focus. I wanted to zoom out a little bit and tell you 3 areas where I'm personally very, very excited about the impact of graphs. And the first one is what I call graphs are saving the world, or graphs are used for social good. And this is something that I'm personally very, very, very interested in and intrigued by. And there's a number of interesting things happening here. By far the one that has gotten the most attention, in particular over the past few weeks, is of course the Panama Papers. And Rick and Holger mentioned this up front. And we're going to have a dedicated session to it before. But just as a short summary that I'm sure most of you know, there's a newspaper in Germany called Süddeutsche Zeitung who was contacted about a breach or a leak, a data dump from a law firm in Panama, which is specialized in what's called offshore accounts. And they got a dump of all the documents for this law firm from 1977, late 70s, all the way up until now. So think about that. This is a dump of every single email, every single, tax filing, documents, scans, PDFs, images of passports, all of that, 2+ terabytes. It is the biggest leak in journalist history. We have a couple of other leaks here, and this is the size of them compared to the Panama Papers, which is just massive. So the Süddeutsche Zeitung realized that they couldn't handle this by themselves. So they contacted a group of journalists called the ICIJ, the International Consortium of Investigative Journalists, who had become famous for being able to manage and work and make sense of these types of leaks. They worked on, for example, the HSBC Swiss leaks a couple of years ago. And they said, help, can you help us out here? And they started out this investigation where they analyzed these 2+ terabytes worth of documents and started making sense of them. And they revealed things like the Prime Minister of Iceland, Sigmundur Gunnlaugsson, who ends up being connected to someone who is connected to a company which is somehow connected to a potentially suspicious tax evasion type offshore account. And of course, as we know, the Prime Minister of Iceland subsequently resigned after this was announced. Getting from point A to point B, from scanned documents and pictures of passports into a graph that you can use to uncover these implicit or explicit connections is a non-trivial task. So I really urge all of you to stick around to that session with Mar tonight, where she's going to walk you through in much more detail than I can what technologies and tools that they use to make sense of all this information. So this is graphs being used as a fraud investigation tool, if you will, forensically looking at data about the past, about things that have happened. Could graphs have been involved somehow in preventing this, right? So in order to prevent something like this from happening, you would need a global database of companies and their subsidiaries, their corporate structures, their shareholders, board members, officers, etc., and how they're all connected across countries and across jurisdictions. It turns out that such a project exists, and it's called Open Corporates. And they do exactly that. It's a very exciting project. They now have almost 100 million companies registered in the database, which blows my mind. Almost 100 million companies. And they store not just these data points in isolation, but they store the entire graph. And it's all backed by Neo4j. So if you go onto there, you can search for Goldman, right? And then you'll find over 1,000 hits. And you're going to be able to click on the parent Goldman organization. And you're going to see all the direct subsidiaries. And then you can navigate from there across countries, across jurisdictions. Pretty amazing. Getting outside the world of corporate law and legal entities, etc., into a completely different arena where we see graphs being used today. And let's enter the world of biology. It turns out that biology is a lot about graphs. Protein networks in your cells, networks are graphs. But even how small and big components of your body is connected and how they react with one another. And what happens if a part of your body is affected over here, how does it affect the rest of your body? That's a very graphy thing. And we see a lot of researchers now who are able to apply a graph perspective on the research on how the body is working internally. Zooming out of the human body, it's also, we see graphs frequently being used to track things between human beings. So this is an example of a disease spreading. And graphs are now being used to monitor diseases and how they spread through a population in real time so that we can stop that from happening. There's a startup called Red Basin, which combines these two approaches, where they take a vast amount of data sources from the microscopic proteins and genes and stuff like that to the more macro perspective with FDA approvals and research and clinical trials. And they put that in a big cloud service into a huge graph backed by Neo4j that they then expose to the researchers. They don't add any new data. They take data that is already existing, but it's existed only in silos. And they make that available for researchers to draw insights from and make sense of that data. And this is what I personally think one of the most important projects of mankind right now, is helping to accelerate the search for the cure for cancer. So that's one big area where we see graphs being used today, graphs for good, that I'm personally very excited about. Another one really centers around the disruptive power of graphs. So probably the best story that I have around how graphs can be disruptive dates back to actually around the same time as we got started with graphs, which is search in the late 90s. I kind of mentioned a couple of names before. Some people even laugh because they're, they're not household names anymore. Lycos, AltaVista, Excite, etc. Back in the late 90s, there were 50 search engines for searching the web, and they all did the same thing. And then a small startup came along, and they did exactly the same thing as everyone else. But they also said that, hey, you know what? Data in isolation is amazing, but let's not ignore the connections implicit in every single web page, the href links. So let's take that, let's extract that, let's build a technology stack from the ground up, centered around processing graphs, and let's use that to rank the search result. Of course, that tiny little startup was Google. That algorithm that they invented, the graph algorithm, is called PageRank. Actually, the name is actually after one of the founders, Larry Page. It's not after webpage. Which is a little trivia. But that key innovation, that one innovation, was what ended up, turned Google into this household name that it is today, and the most dominant company of at least the previous decade. And all these other names are names that we kind of laugh about. AltaVista, yeah, remember that, ha 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 ha, right? And what I think is really, really amazing with Neo4j at this point in time is that what you're able to do, a two-person startup now has the power of the Google technology stack in your hand with Neo4j. And this, I think, is an absolutely amazing thing, because anyone with an idea and a purpose can now use a technology that is powerful enough to change an entire industry, just by downloading something off of the internet and use it for free. So I'm personally very excited about this one. And we have a number of startups that are using this today. One of the big web scale companies, of course, is Twitter. One of the founders of Twitter have moved on and have founded a new company called Medium that I'm sure many of you are familiar about. And they're really trying to disrupt the content industry, the publishing industry, with long-form content. And they are very centered around Neo4j for doing recommendations, for storing their social graph and followers and followees and how their content relates to other content. There's another startup that is actually here today and talking today called Wayblazer, who's doing some amazingly cool things with a combination of graphs and Neo4j with IBM Watson, and use that to disrupt the travel industry. So Graph Connect is this annual conference that we run twice per year. Once per year in San Francisco and once per year in London. And so 6 months ago, we at Graph Connect in San Francisco, we launched the Neo4j Startup Program, where we give away Neo4j Community, of course, available for anyone to use for free, but we give away Neo4j Enterprise, the Enterprise edition of our software, to startups for free. And we launched it 6 months ago, the startup program. Here are some of the logos that have signed up. And today, as of this morning, we had 273 startups sign up for this program. And I think this is amazing. I was just talking to a journalist yesterday who was blown away by this because he had previously spoken to SAP, who has launched a startup program, had it available for a long time, and they have slightly more resources than we do, temporarily. And they were super proud that they'd finally gotten across the 100 line of startups. But now in 6 months, we have 273 startups signed up for our startup program. You won't recognize any of these logos here, right? But every one of them has the power of the Google technology stack in their hand, right? And my bet, I'm willing to bet, that over the next 10 years, one of these 273 startups is going to emerge as that next big household names, based on the power, the disruptive power of graph databases. So that's the second area. The third area where we see a big impact of graphs is, of course, small and big companies using graph databases to accelerate their business. Graphs are a completely horizontal phenomenon, but what we're starting to see right now from a commercial perspective is that we see some patterns emerge where we see most of the commercial traction for graph databases. So I'd say probably 70% of the commercial use cases in big companies for graph databases really are bucketed in 6 core use cases. And the first of those use cases is real-time recommendations. So Walmart has for, I don't know, decades been storing your purchase history, right? When you buy something on Walmart, the Fortune 1 company, the biggest company on the planet supposedly. When you buy something, I don't even know if Walmart is available here in the UK, but in the US, if you buy something at Walmart, like that will be tracked in a big purchase history, which traditionally has been stored as a big table, rows, right? But what they found out and figured out was that if I take that same purchase history and I have a graph view on it instead, so I say that, Emil has bought these 3 things, and Jim has also bought these 3 things. Seems like they have things in common, right? Okay, cool. But Jim has bought also this 4th thing, which Emil hasn't bought. Awesome. Let's take that 4th thing and recommend that to Emil, right? That should make sense. And that's a simplified view because in reality, it's not that simple. You in reality want to look at product categories. So if that 4th thing happened to be The Two Towers by J.R.R. Tolkien, for example, you probably don't always want to recommend it specifically that product item, but something that belongs to that category, right? Because that book belongs to the fantasy category, which belongs to the fiction book category, which belongs to the book category. And then we would want to jump up 1 or 2 levels in that hierarchy and recommend something there. And if you take that hierarchical approach to all these things that they have in common, all of a sudden we're talking 10, 20, 30, 50 hop in the data structure, which is something that uniquely graph databases can do in real time. So that's one very popular use case. Another one, fraud detection. And we've already talked through this with the Panama Papers, which really is fraud investigation. We see a lot of big banks, Fortune 100 banks, and a lot of big government that are using graph databases to detect fraud after it's happened and to detect it in real time and prevent it from happening. Very popular use case. Network and IT operations, fundamentally very network-oriented, of course. If you're a big telco and you're managing a network, that's a graph, right? And if you want to know what happens if this cell tower is blown down, right? Or if this firewall is going down, how will that cascade across my network? Or if you're a big enterprise, what happens if this part of my network gets breached and compromised? How will that cascade potentially across my entire enterprise? Very popular. HP has a product in this area, which is centered around Neo4j. Master data management has a lot of hierarchical data. It has traditionally had taken a very silo view on master data. But there's a lot of hierarchical data involved. And 5 years ago now, Cisco started using us for the vast majority of their master data management. And this is one of the most popular use cases for graph databases. Graph-based search is a little bit the Google use case, where you used to be able to just look at documents in isolation and just search internally at documents. But then someone figured out that, hey, what if you also look at that document and how it relates to other things and use that to rank your search results? And Lufthansa is using Neo4j to do that. And then finally, identity and access management, which is very similar to that original use case that we had, where we had content and assets, and that's related to groups and groups of people and groups of groups, and with security permissions left and right. And storing that is a big, big graph. And we actually have a local team here in London at UBS doing that with Neo4j. So these are some quite amazing use cases. Some of them are used to grow the top line, right? Like, for example, real-time recommendations, right? Others are centered around the bottom line, like the fraud detection. But they're all about accelerating some company's business using graphs. So that's the third big area. Those 3 big areas where I see that graphs have a global impact right now. But I want to take a step back and talk a little bit about the technology that is underlying this trend. Fundamentally, if you look at the audience demographic, it's about 70% of people who are technology practitioners in here. And about 30% are IT executives or others. So I want to make sure that we spend some time on hands-on how we actually gain value from using graph databases. And if we ask users, and there's many of them here in this room, we ask users what they love about Neo4j. We consistently hear three things highlighted, and they really straddle the entire software development lifecycle: design, develop, and deploy. And it's consistently three things that we hear back. One of them is whiteboard friendliness, or the flexibility of the model. The observation that once you've modeled something with a graph, you can take a business person who doesn't know anything about ER modeling or third normal form or something like that, and you can actually show them the graph, and it makes sense to them, right? That is something that I think is super powerful, and we haven't yet reaped all of the advantages of that, right? Being able to use something as fundamental as a data model to communicate between technical and business stakeholders is very, very powerful. This is also the flexibility of the model that I discussed earlier, where you can start out as a social network, but then you get the idea that, hey, I want to actually also build an auction site, and you start evolving the data model. So that's one of the things that we hear consistently. As people start building applications, the query language Cypher, people love Cypher. It's a fantastic way of succinctly expressing graph operations. And once you deploy it into production, we have that native graph performance where you can do operations in milliseconds that takes minutes or sometimes hours in other types of databases. If we ask users what they want more of, you can always improve, you can always build out your product, right? It also straddles these three parts of software development lifecycle. The first one that we hear very loudly and very clearly is that people want to design bigger and faster graph applications. They want to do that faster in a more productive fashion. And they want to deploy them seamlessly anywhere, like on-prem, off-prem, containers, etc. So I want to give you now a little bit of a sneak peek, a little preview of what we're working on right now with Neo4j 3.0 and how that maps to some of these themes. And I'm super excited about the upcoming Neo4j 3.0 release. In fact, for a while we were discussing, in this keynote, if I would talk about some of the aspects, and then Philip, the head of product for Neo4j, would come up and talk about Neo4j 3.0. But I'm just so excited about the features that we're going to launch in 3.0, and I think you're going to be that too, that I just have to be here to tell you about it. So I want to zoom in on one of these two things, right? One of these three things, which is developer productivity. And the first thing that we're building in 3.0 aligns very well around productivity of developers. And that is coming back to that original napkin. So we designed this data model, the property graph data model. And the question then is, OK, once you have the data model designed, how do you expose it to developers, right? And we've done that in various shapes and forms and modalities over the years. In the 0.x release, we really were an embedded Java library, right? So we were embedded Java database, where you drop this in as a jar file, which hopefully makes sense, at least will make sense to the developers in the room. And then it's available in process, and you have an object-oriented API which maps directly to that data model. So that was really how we thought about how to expose it to developers in 0.x. In 1.x, we added an HTTP API, a way of interacting with the data model and manipulating it over HTTP, and we call that our REST API. 2.x was really when Cypher grew up. In the 2.0 release, we added what we deemed as the we filled the last remaining gap in order for Cypher to be a first-class citizen, which was the ability to create and change indexes, right? So Cypher really became the preferred way of interacting with Neo4j in the 2.x release. In the 3.x release, we are going to build on the success of Cypher but do that by wrapping this in official language drivers. This one may seem like a small detail. It may seem like, okay, well, of course, we're going to have drivers. Okay, let's move on. But it turns out that this is actually a very impactful feature. So let me give you an example of this. This is a real-world question from either Quora or it looks like Quora, where someone is asking, okay, I'm a Java developer. I'm maybe working at a big bank in London, and we're standardized on Java. You know, in the evenings, I hipster out with Ruby and Rust and whatnot. But during daytime, I'm a Java developer at a big bank. And so I know that I'm going to use Java. I know I'm going to use Neo4j. How should I use Neo4j from Java? Should I be calling REST functions directly? Should I be using the REST binding? Should I be using the Neo4j JDBC binding? Or should I be using Spring Data Neo4j? And of course, even the premise of that question hurts to someone like me, right? Like I think our job is, like, if you know that you're going to use Neo4j and you know that you're going to use Java, we should say this is the best way to interact with Neo4j from Java, right? But let's double-click on one of them, calling REST functions. Let's say that this individual then chose calling REST functions directly, and they wanted to do something simple as, you know, give me all the person nodes in this graph, and in fact, give me all the names of the person nodes in this graph, right? Which is very simple and easy to express using Cypher. You know, match n, that is a person, you know, return n.name, right? Super simple. The code for that isn't as simple, and you probably can't see it in the back, but the details don't matter. It's readable code, but it's kind of awkward, right? This uses the same API as if you wanted to connect to the Facebook Graph API or to Twitter's API, right? It is not optimized for database access. The equivalent example in Neo4j 3.0 is going to look like this. Again, the details don't matter so much, but the intent here, I think, is much clearer. You get the driver out of the graph database. Out of that driver, you get a session. Through that session, you pass along a Cypher query, and you get the result back. Done. Right? Super simple. Officially supported driver in Java. We also have one in JavaScript, where you can see it's very similar. We also have one in Python that is part of the official release, where the code looks like this. You can see it's a very, very consistent surface. Syntactically, sometimes consistent, but we've chosen, of course, to expose this in a way that is idiomatic to the language over consistency across languages. But it's conceptually consistent. What I mean by that is that when you get a specific data type back from Neo4j, it will be consistently interpreted across languages. All the other concepts that aren't directly part of the data model, what I think of as kind of the driver model, things like transactions, statements, sessions, result set, all of those are unified in a conceptual model across these languages, which makes it a lot easier when someone is, you know, when you're online and you're a Java person and someone from the Python community is helping you out, and when they say, open up a session, that thing means the same thing for a Python developer as for a Java developer. We also officially support .NET, which looks, of course, very similar to Java. So we're super excited about this. With 3.0, we will release support for 4 official languages, but we're working very closely with the community. We have an amazing community of drivers. And I think I'm not going out on a limb here when I say that there's going to be a number of them available very shortly after the 3.0 release. I know for certain that the PHP one will be available very shortly after we release Neo4j 3.0. This builds on a foundation of something that I think is very, very exciting, which is we've now replaced HTTP with a new protocol. We've invented a new protocol, which is inspired by MessagePack by Google, for those of you who know that we call Bolt. And it's a binary protocol. It's stream-oriented. It's secure by default. And it's completely optimized for graph operations. And it enables many of the amazing things that you see in Neo4j 3.0. If you want to geek out more on that, which I urge you to do, actually, there's a session in this afternoon, I think at 1 p.m., where Nigel, and maybe someone else, but Nigel from the drivers team is going to go through the finer details of the Bolt protocol and the drivers. So that was very amazing. Super excited about that one. Another thing that this new client surface allows you to do is what we call Java stored procedures. Java stored procedures. And the way that we think about this is that Cypher is the best way that at least we have been able to figure out in order to succinctly express graph operations. And there are things that you can do in Cypher in a couple of lines of code that take hundreds of lines of code in a general purpose programming language, right? So that's the way that it should be. You can think of it as a DSL or a specialized language for graph operations. But there are always things that a general purpose language will be able to do better than Cypher. So think of if you have two Cypher statements, you may want to chain them together using some conditionals. Sure, that's doable in Cypher, but it's just easier to express using a general purpose language like Java. Or imagine that, I'm going to be creating a bunch of nodes, but I want to assign a unique identifier to every node, right? Like kind of a sequence thing. And I want that to be a globally unique identifier, like a UUID, universally unique identifier, I suppose. Like, can you do that in Cypher? I'm sure someone can figure out a way of doing that in Cypher, but it's very easy to do in a general purpose programming language. And so what we can do with this new facility that is included in Neo4j 3.0 called Java stored procedures is a way of seamlessly drop down from Cypher into Java and then back out again. So hanging on to that example of UUID, let's say that we wanted to do that, then we would write this one-liner. There's a little API, a stored procedures API, if you will, which we won't go into the details of, but you can see that it just invokes a standard API in Java called UUID, which is Java's standard way of generating UUIDs. You wrap that in some result sets and some APIs, and then you return it out. One-liner. Once you do this, you deploy that onto the Neo4j cluster. After that, in Cypher, you can just call this function. We happen to call this function generate.uuid. You can just call that from Cypher, call generate.uuid. You're going to get the result back. You use the yield keyword to map that into a variable in Cypher. And then you can just use that. And this facility is so amazingly powerful. The fact that you can use Cypher, what it's awesome at, graphs, and then drop down into Java for general purpose stuff. And by the way, you can use any language that's supported by the JVM, so JavaScript or JRuby or whatnot. And then drop back up to Cypher again for doing the graph optimized things, and then back down into Java, back out into Cypher, and mix them, commingle them. I think that's going to be completely revolutionary in terms of how we write client applications using graph databases. So we started this project, I mean Michael Hunger, for those of you who know him or know of him, started a project where he got so excited about this feature that it's like, okay, by the time Neo4j 3.0 launches, I'm going to have 100 Java stored procedures in an open community contrib directory. And so he's written many of these by himself. Other people have contributed in the community, et cetera. And there's some pretty crazy stuff available out there already, even though 3.0 hasn't even been released yet. So one example of this, the code won't be visible here, but it's a stored procedure called JDBC, which you can pass in a JDBC URL to. You pass in any JDBC URL. This one seems to be connecting to MySQL and the Northwind database, the stereotypical SQL example, right? And you pass in the table name, and then all of a sudden, back in Cypher, you're going to get every single row of that table, and you can operate on that. And I guess this query just returns it, so then it looks like just a normal Cypher query returning a result like this. But of course, you can operate on this, right? So rather than just returning it, you can start using the normal Cypher constructs for manipulating the graph, like create and merge, et cetera. And all of a sudden, you have a couple of lines of code. You're grabbing data out of MySQL, and reformatting that, extract the graphness of that data, and add it to Neo4j. Right? And people are writing these integrations now, these procedures for Elasticsearch, for Mongo, for Cassandra, etc. Another example, which doesn't use a return result, is called MetaGraph, which takes an unknown graph database, and it looks at the shape of that graph, and it says that, hey, by the way, like this is the metastructure of your graph. You have a lot of users. Users are connected to shopping carts. Shopping carts are connected to products. So they extract the schema, if you will, of that graph database. These are just a couple of examples, 2 examples from this contrib. But once Neo4j 3.0 is out there, I really urged you to sit down and play around with Java stored procedures. And if you write something that is generic, contribute it out to the community so others can benefit from your amazing high-quality code. So that's on the productivity side. Switching gears a little bit and talking about scale. So Neo4j today is one of the most scalable databases on the planet. There was a blog post a few days ago where an independent consulting firm had embarked on a project to create an architecture and an implementation for a 1 billion member social network. And it's available. It's just posted 4 or 5 days ago. You can Google and read up. It's very interesting. They evaluate graph technologies and conclude that by far the best graph technology for storing all this was Neo4j. And of course, a 1 billion member social network, that's pretty big, and 1 billion nodes at least. But then, of course, it drags into that graph posts and likes and all the relationships between all the different members, etc. Available, works on Neo4j 2.3 today. Some of the biggest companies on the planet are running some of the biggest applications on the planet on Neo4j today. But we've always seen, just generically in engineering, there's this inherent tension between scalability and performance. And I think of it as kind of the CPU memory trade-off that all developers know. But maybe a simplified view is that it's easy to make something that is small and fast, but if you make something that is big, you have to make it slow, right? Big and slow is easy, small and fast is easy, but the combination isn't easy, right? So for that reason, Neo4j has been capped at a very high ceiling, but has always been capped. We haven't allowed massive graphs. You can do graphs of tens of billions of nodes, 20 billion nodes, but it's capped at around 40 billion in Neo4j 2.3. And we've done that in order to make sure that we can always have this native graph performance that people keep citing as one of the key benefits of Neo4j, the millisecond performance for operations that may take minutes or hours in other types of databases. But we've also loudly and clearly heard the people ask for this increased scalability, right? The ability to support massive graphs. We've spent a lot of time in the engine room, and the engineering team has figured out a way of combining massive scalability with native graph performance. And this makes it possible for Neo4j to support unlimited sized graphs. And this one, I think, is a game changer. Now, how big of a game changer is interesting to think about, because when do you need unlimited sized graphs, right? And honestly, the answer is that today, almost never, or at least very, very seldomly. Like, for example, let's say that we're working in healthcare, and we're building an application for some hospital in London, like the Royal Hospital in London. I assume there's a Royal Hospital in London, or the Queen's Hospital in London. It's going to be that. Imperial College? I don't know. OK, some hospital in London, right? Neo4j today can store, if you take the entire graph of that hospital, that can easily be stored in Neo4j today. In fact, if you take all the hospitals in the UK and you chain them together, that can easily be stored in Neo4j today. In fact, going even further, like if you take all the hospitals in the world, you chain them together, put all of that data into a massive graph, that can easily be supported by Neo4j today. But of course, the world that we're going into and the world that we're designing Neo4j 3.0 for is not the world of today, it's the world of tomorrow, right? And healthcare will definitely change dramatically over the next, say, 10 years, where today, doctors are working with data sets in isolation. They do some examinations and they work on that data in silos, right? But over the next 10 years, all of this data is going to get linked up and related and connected. And not only that, but today you have this paradigm where you see your doctor once every 6 months or 12 months or whatever, right? But of course, 10 years from now, like all of us in this room, minus the 1% who are Luddites, right? But all of us in this room are going to have 2, 3, 4 devices on our body that is tracking our heart rates, tracking our blood pressure, tracking like all kinds of signals on our body, and is sending that over to our hospital, right? And they're probably going to be regulated, where they have to store this data for years and years and years. And that is a massive size graph. And that is the world that we're truly designing Neo4j 3.0 for. So, in summary, there's actually a bunch more things in Neo4j 3.0 that I could have talked about. It would have made an almost as exciting talk. There's a cloud sync of your Cypher bookmarks that I haven't talked about. There's an significant operability improvement that makes it easier to deploy on cloud, in containers, on-prem. And there's a bunch of other things that are in Neo4j 3.0 that I haven't even mentioned. But these are the 3 things that I'm the most excited about. The officially supported drivers with a consistent and unified surface. The Java stored procedures that allows you to use Java for what it's best at and Cypher what it's best at in a seamlessly integrated fashion. And then, of course, unlimited sized graphs. It's the most significant release for sure that we've ever done for graph databases, and it's the one that I'm personally the most excited about. And the best part about it is, of course, the question from the audience then is, so when is this available, right? Well, the best part about this is that earlier this morning, the engineering team cut to GA of Neo4j 3.0, so it is available right now. So here is where I want you to challenge my previous statement about the amazingness of Europe versus European telecom infrastructure versus American one, and really go online right now to neo4j.com/download, download Neo4j 3.0, and start playing around with it. I think it's an absolutely amazing release. All right. Taking a step back, some closing thoughts to wrap this up. So, what is very clear and obvious, at least to us now, and I hope we've been able to communicate that to you in this past 45 minutes, is that we're entering the connected age, right? Everything is becoming more and more connected. People are becoming increasingly connected. Devices are becoming increasingly connected. Everything is becoming increasingly connected. And it would be very naive, I believe, if we thought that our data, the shape of our data, wouldn't follow that. On the contrary, over the next 5 to 10 years, data will only become more and more connected. If you look at a chart of the number of connected devices going forward, and you talk to most industry experts and analysts about this, they predict that by the end of this decade, there's going to be somewhere between 50 to 75 billion connected devices on this planet. And that's an interesting number because it maps very closely to the amount of neurons in the human brain. We have roughly 68 billion neurons in the human brain, 200 to 300 trillion of synapses, the connections between them. And I'm always excited when I have the opportunity to show this slide because I do think that the absolute best database on the planet is that thing. It's the human brain. Maybe rivaled by Neo4j 3.0. Maybe. And how's that structured? It's structured as a graph, right? Neurons connecting to other neurons through synapses. And at Neo4j, we see the database landscape, and there's a lot of great databases out there who are massively scalable, and they're robust, and they do all kinds of amazing things, right? But fundamentally, what they do is that they store stuff, and then they retrieve stuff, right? Store data, and then you retrieve it later. Yes, scalable, yes, cloud-friendly, I'm sure, all kinds of good things, right? But fundamentally, it's about storing stuff and then retrieving that back out again. And we have much, much higher aspirations than that. We want to help you guys make sense of your data. And we think that a graph model is an amazing way of doing that by connecting things, much as Mar and her ICIJ team did with the Panama Papers. You made sense of that data through understanding the connections in them. And that truly is what we hope that we enable you to do with our database. I started out this talk with one ground rule, right? The ground rule of don't give me your full attention and tweet about this. So I hope you've done that. I want to end with some homework for you. And the homework is the same homework that I always give everyone at Graph Connect. So for those 30% or so that stood up for 2015, you'll remember that. And it's kind of a way to remember that we're all graph people in this room. There's a bunch of other data models out there, like there's documents, whatever, key value pairs, et cetera. But they're not connected to other things. The difference with graphs versus any other model is that connections are front and center in everything that we do, right? So live that today. Don't be a tragically isolated document today. Form relationships. Talk to your fellow attendees. Ask them, when did you first hear about Neo4j? What are you building? What do you find exciting about it? What do you wish they would improve about it? Strike up conversations. Build relationships. And in one word, of course, connect. Thank you very much.